Splicing aluminum to copper wiring requires careful consideration due to the different properties of the two metals. When dissimilar metals like aluminum and copper come into contact in the presence of moisture, a phenomenon known as galvanic corrosion can occur. This corrosion can degrade the connection over time, leading to increased resistance, overheating, and potentially fire hazards. Therefore, simply splicing aluminum to copper in a junction box without proper connectors is not a safe practice. To safely join aluminum and copper conductors, you must use connectors that are specifically designed and listed for this purpose. These connectors typically employ a barrier compound or coating that prevents direct contact between the two metals, thus minimizing the risk of galvanic corrosion. These connectors are often labeled as ALCU or CUAL, indicating their suitability for joining aluminum and copper wires. When installing these connectors, you must follow the manufacturer's instructions carefully. This includes properly preparing the wire ends, applying any required antioxidant compounds, and tightening the connectors to the specified torque. Torque is critical to ensure secure and reliable connection. Under-tightening can lead to loose connections and overheating, while over-tightening can damage the conductors or the connector itself. In the context of creating a subpanel 150 feet from the main shop service, the following points need consideration. Firstly, the existing size 4 aluminum service cable must be properly rated for the intended load of the subpanel. Size 4 aluminum wire has an ampacity rating that depends on the temperature rating of the conductor insulation. According to the National Electrical Code, specifically Table 310.16, size 4 aluminum wire with a 75 degrees Celsius insulation rating is typically rated for 60 amps. However, this rating can vary depending on the specific installation conditions and the type of insulation you used. You must verify the ampacity rating of the existing wire to ensure it can safely handle the anticipated load of the subpanel. Secondly, the distance of 150 feet introduces a voltage drop consideration. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate the voltage drop for the 150-foot run of size 4 aluminum wire, you need to know the total current that the subpanel will draw. The formula for calculating voltage drop in a single-phase circuit is voltage drop equals 2 times the length of the conductor times the current times the resistance per foot, all divided by 1000. You can find the resistance per foot of size 4 aluminum wire in electrical engineering handbooks or online resources. If the calculated voltage drop exceeds the recommended limits, you may need to increase the size of the conductors to reduce the resistance and minimize the voltage drop. Thirdly, the grounding of the subpanel must be done correctly to ensure safety. The grounding conductor provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock hazards. The grounding conductor must be properly sized according to the National Electrical Code Table 250.122, which is based on the size of the overcurrent protection device protecting the circuit. The grounding conductor must be connected to the subpanel enclosure and to the grounding electrode system at the main service. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. Fourthly, the overcurrent protection devices, such as circuit breakers or fuses, must be properly sized to protect the conductors from overloads and short circuits. The overcurrent protection device must be rated to protect the smallest conductor in the circuit. In this case, if you are splicing the size 4 aluminum wire to a copper wire of a different size, the overcurrent protection device must be sized to protect the smaller of the two wires. The National Electrical Code Article 240 provides detailed requirements for overcurrent protection. Fifthly, the junction box where the aluminum to copper splice is made must be properly sized and installed. The junction box must be large enough to accommodate the conductors and connectors without overcrowding. The National Electrical Code Article 314 provides requirements for junction box sizing. The junction box must also be securely mounted and accessible for inspection and maintenance. Sixthly, it is important to consider the type of load that the subpanel will be serving. If the subpanel will be serving sensitive electronic equipment, such as computers or audio equipment, you may need to install surge protection devices to protect the equipment from voltage spikes and surges. Surge protection devices can be installed at the subpanel or at the individual equipment. Seventhly, you must comply with all applicable electrical codes and regulations. The National Electrical Code is the most widely adopted electrical code in the United States, but local codes may also apply. You must consult with a qualified electrician or electrical inspector to ensure that your installation meets all applicable requirements. Eighthly, when working with electricity, always take necessary safety precautions. Turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Ninthly, ensure that all connections are accessible for future inspection and maintenance. Do not bury or conceal connections in walls or ceilings without providing access panels. Regularly inspect electrical connections for signs of corrosion, overheating, or damage. Tenthly, documentation is crucial. Keep records of all electrical work performed, including wire sizes, connector types, and overcurrent protection device ratings. This documentation will be helpful for future maintenance and troubleshooting. The existing size 4 aluminum service cable needs to be evaluated for its suitability for the new subpanel. Firstly, verify its ampacity rating based on its insulation type and installation conditions, referencing the National Electrical Code Table 310.16. Ensure the ampacity meets or exceeds the calculated load of the subpanel. Secondly, perform a voltage drop calculation considering the 150-foot distance and the expected load current. Use the formula voltage drop equals 2 times length times current times resistance per foot divided by 1000. Compare the result to the recommended voltage drop limits of 3% for branch circuits and 5% for feeders. If the voltage drop is excessive, consider increasing the conductor size. Thirdly, confirm the existing grounding conductor is adequately sized according to the National Electrical Code Table 250.122, based on the subpanel's overcurrent protection device rating. Ensure it is properly connected to the subpanel enclosure and the main service grounding electrode system. Fourthly, size the overcurrent protection devices, such as circuit breakers or fuses, to protect the conductors from overloads and short circuits, adhering to the National Electrical Code Article 240. The rating should not exceed the ampacity of the smallest conductor in the circuit, especially at the aluminum to copper splice point. Fifthly, the junction box housing the splice must be appropriately sized according to the National Electrical Code Article 314 to accommodate conductors and connectors without overcrowding. It must be securely mounted and remain accessible. Sixthly, consider the nature of the loads the subpanel will serve. If sensitive electronic equipment is involved, install surge protection devices at the subpanel or individual equipment locations to mitigate voltage spikes. Seventhly, adhere strictly to all applicable electrical codes, including the National Electrical Code and any local amendment. Consult a qualified electrician or inspector to ensure compliance. Eighthly, prioritize safety by energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. If unsure, engage a qualified electrician. Ninthly, ensure all connections remain accessible for future inspections and maintenance. Avoid concealing connections without access panels and conduct regular visual checks for corrosion or damage. Tenthly, maintain comprehensive documentation of all electrical work, including wire sizes, connector specifications, and overcurrent protection device ratings for future reference during maintenance and troubleshooting. It is essential to consult with a qualified electrician to ensure that the installation meets all applicable codes and safety standards. A permit and inspection may be required for the electrical work. Remember that improper electrical work can lead to serious safety hazards, including electrical shock, fire, and equipment damage.